All right, so I'm looking at the 3-1-3-3, 189, 190 review. Let's talk about that, see how we do. Someone says in a 50-yard dash, my time is at a z-score of +2. Explain to them what that means in a sentence in the context. There are 2 standard deviations above the mean. They did better than 84% of the other people because a z-score of 2. This is a z-score. It can also be a standard deviation. Okay, if they are 2 above the mean, that means that you add all of these areas up. Okay, and then we can go. I'll write up that whole thing. But does everyone understand how to decipher with our? Let me see if I can draw this as neat as possible, but I'm going to fail at it. You know that.
You've been kind of on a roll, sir.
You know, every now and then I get kind of lucky. Okay, mean, 1 standard deviation, 1 standard deviation. 2 standard deviations, 13.5. Negative 2 standard deviations, negative 13.5. And then all right, 3rd standard deviation, 2.35. And then if I go to the outside of that, what's the color I haven't used? Let's go purple. 0.15%. 0.15%. Okay, so the easiest way to do this, you could try and add up all of the areas, which becomes a lot of things to add up. What you should realize is if you are at this point over, you're talking about 50% of your data that way. This point over is 50% of your data that way. So this person who is at 2 standard deviations above the mean, okay, I'm actually going to erase that, but in a sec, 2 standard deviations above the mean, there's no reason to go 0.15 plus 2.35 plus 13.5 plus 34 plus 34 plus 13.5. Okay, you can go 50% plus 34.5 plus 13.5 and get to 84, or 2 standard deviations was 84 plus 13.5. I was actually off on my answer. I'm sorry. You can't take me anywhere. So someone who is 2 standard deviations above the mean as far as their run meant they did better than 97.5% of the other people. Only 2.5% did as well as them. So that's what it goes to. And it really comes to this line of best fit. Or not line of best fit, but it goes with this equation. Find a z-score when somebody has 14,000 words. Okay, I will write up the z-score equation, z-score of 22,500. I'll write up the z-score. Someone who has a z-score of negative 1.6 would have how many words? That means you're doing the z-score equation. Z-score is observed minus the mean over the standard deviation, right? So if you were looking at the one, if they told you somebody has a z-score of negative 1.6, that means you're going to go negative 1.6 observed minus the mean. I don't know what the mean was. 20,000. And then standard deviation of 4,000. So then this is just an algebra 1. This is an algebra 1 problem to solve it. This is your variable. This is what you're looking for. Okay? So multiply both sides by 4,000, add 20,000 both sides, and that would be the observed score. Okay? Make a bell curve showing the 7 positions. Friends, no one should miss that one because that one will stay up on the board. Okay? So it's also possible on the normal distribution. I'm not going to write them all in, but it might say, hey, what percent would fall here? So you're just adding up those regions. I don't have them all written up there, but you'd add the 34, the 34, and the 13.5. Okay, that's how much data would fall between those two things. So everything's going to fall on a standard deviation. They might call the standard deviation a z-score. The only time they give you a z-score as a decimal is if you're finding the observed value. So let's put a few things up on the board. Let's do this. Okay, come on, Stirrup, you can do this. Okay. I'm going to go back to my chart so I know how to do it. Okay. The mean, x bar. Okay. Plus 1 standard deviation, or that could be a z-score. Minus 1 standard deviation, or it could be called a z-score. Okay. Here is 34%. Here is 34%. 2 standard deviations could also be referred to as a z-score. -2 standard deviations could be a z-score. 13.5% goes here. 13.5% goes here. Going out one more. Standard deviation can also be called a z-score of 3, 2.35. Go this way, -3. Standard deviation can also be called a z-score, 2.35. And then if our graph keeps going, and our graph will never cross or touch the x-axis. For your algebra 1, it might be called a asymptote. Okay, does that make sense? Can everyone understand that? If that stays up there and I say, hey, write the 7 positions on a normal curve, can you do that? Can you copy from here to your paper? Good. All right. The z-scored equation is the observed minus the mean over the standard deviation. Okay? So they might realize that the mean can be given to you as something like that. The standard deviation could be a symbol like that. Okay? I don't think I have any goofy symbols on there. Let's see what else is on this quiz. Okay. Yeah, it's there. There's very little. Oh, what does it mean if I get a z-score and the z-score happens to be negative? Does it mean it's a bad answer? What does a negative z-score mean? Yeah, it's on the left side of the mean. Okay, for it to be a normal curve, we also want the standard deviation to be equal to the mean. Okay, if it's not, then it might be skew right or skew left. I'm not looking for the term skew right or skew left. It's just if the mean and the standard deviation don't come out the same when looking at it, be cautious. Is there anything else? Oh, and then so realize if you have a certain data that they say forms a normal curve, if you had, let's say we had that, okay? So this would have a mean of 4.5. It would have a standard deviation of also 4.5, or not standard deviation, excuse me. um, not standard deviation. This shouldn't be standard deviation. What am I looking for? Median. Jeez. No, I'm going to keep it up there on the board.
No, I said, have you had your coffee yet?
Yeah. This is my second full one. And it's the third gone. So I've had 1 1/3 of those.
So
All right.
you're just
Yeah, I'm just being dumb. Just being dumb. So if they say, hey, is this a good thing of data? Let's say they tell you that the standard deviation from this is equal to 6. This does not form a good normal curve because of this fact. If I went to my mean, I added 6 to this, I get to 10.5. If I subtracted 6 from this, I get to negative 1.5. That means 100% of our data falls into the region that only 68% should be there. Does that make sense? So if this was the information, now I just made this up, so don't go and plug it in your calculator going, you're wrong, Phil. I made it up. The mean, I'm pretty sure, median, I'm sure, I know the standard deviation is totally wrong. But let's just say it's that. If I were to say that, 68% of our information should have fit within 1 standard deviation of the mean. Because my standard deviation is so large, in comparison to our numbers, 100% of our data would fit in between these two. And that's not what you want. You want only 68% of your information here. There is one. Let me see if I can do this right. Okay, I'm going to try something. It's going to be good. So that yellow encompasses 68%. I'm trying it without a net. It doesn't work. Between that, we have 95% of our data. So the blue is 95% of our data. And then one last one, highlighter, go to pink. If I go out to that needs to encompass 99.7% of our data. Okay, so if you were looking at a list up here and it's not falling, if it's falling close, you're probably fine. If you're saying in the region that we have 68% of our data, of 100% of our data fit in there, that's really bad. That means it's not a good normal distribution. Okay? So if I looked at my data that was up here in the upper left corner of the board, if my standard deviation was 6, if I added 6 to 4.5, I get to 10.5, which is way over here, right? If I subtracted 6 from this, I get to negative 1.5, which is over here, which means 100% of my data fit in a region that only 68% of my data should have been in. So that says not a good normal curve. Now, if it was 68% and your data came out to like 70%, you're probably fine. If your data came out to like 66%, you're probably fine. But if 100% of your data fit within here, or fit in within here, which should have been 95%, it's probably not a good normal curve. Yeah.
So one of the reasons, one of the ways we're checking the data, see if it's a normal curve, would be the mean, median, and standard deviation.